Hey guys, I'm making this video series for VTU M3 students, and if you're 21 scheme students, then you will be writing the exam for the first time, 21 or 31, and for 18 scheme students who have M3 backlog. And if you like these videos, please subscribe to our channel and share these videos with your classmates and friends so that it will help them also. Okay, so in this question, f of t is given as t power 5 by 2 plus t power minus 5 by 2, and we have to find f of s, which is Laplace transform of f of t. And Laplace transform is the integral of the product of f of t and e power minus st with respect to t from 0 to infinity. So we don't need to actually integrate anything here, because as we have discussed in previous videos, we already listed basic Laplace transforms. Okay, so one of the basic Laplace transform is the Laplace transform of t power n. So whenever you have t power n, t cube, t power 5 by 2, something like that, the Laplace transform is directly known, okay, which is n plus 1 gamma over s power n plus 1. Okay. So if you have n here, it is n plus 1 gamma over s plus n plus 1. This is not square, this is gamma. Gamma is a function. It's also an integral that you learn later. For now, think of it as an operator. Okay. So this is actually more known as n factorial by s power n plus 1. But this is a more general case. This is the case when n is a positive integer. If n is 1, 2, 3, 4, something like that, then gamma of n plus 1 is actually n factorial. Okay. But in this case, n is 5 by 2. Okay, it's a fraction. So we need to use the more general case. Okay. So if you take Laplace of this, what you will have? Laplace of this, Laplace of f of t is f of s. So that is f of s is equals to Laplace of t power 5 by 2. In place of n, I have 5 by 2. So it is n plus 1, that is 5 by 2 plus 1 gamma over s power 5 by 2 plus 1. Plus, in place of n, I have minus 5 by 2, t power n, t power minus 5 by 2. So it is minus 5 by 2 plus 1 gamma over s power minus 5 by 2 plus 1. Okay. So if I simplify this, this is 7 by 2 gamma over s power 7 by 2 plus this is minus 3 by 2 gamma over s power minus 3 by 2. Okay. So this is not the final answer, because they expect us to write the value of gamma. Okay, gamma of 7 by 2 is some value, some number, some real value. Okay, so how do you find gamma values? So you need to remember, you need to learn three basic formulas. Okay, three basic values. Okay, that is gamma of 1 by 2 is always square root of pi. So this is the value that we know. Gamma of 1 by 2 is square root of pi, and we need to convert every other gamma terms into gamma of 1 by 2. How do you do that? Okay, so gamma of n plus 1 can be written as n into gamma of n. Okay, for if n is greater than 0. Okay, if n is positive value. So in this case, I have 7 by 2. Okay, gamma of 7 by 2 can be written as 5 by 2 plus 1. Right? 7 by 2 is 5 by 2 plus 1. So if you compare these two, n is 5 by 2. So this can be written as 5 by 2 gamma of 5 by 2. So gamma of 7 by 2 is actually 5 by 2 gamma of 5 by 2. And what is gamma of 5 by 2? It can be written as 3 by 2 plus 1. Okay, so it is a 3 by 2 into gamma of 3 by 2. Okay, you understand, right? It's an iterative process. Again, gamma of 3 by 2 is basically 1 by 2 plus 1. 3 by 2 can be written as 1 by 2 plus 1. And if you compare these two, n is 1 by 2. So n plus 1 is n gamma n. So 1 by 2 plus 1 is 1 by 2 gamma of 1 by 2. Gamma of 1 by 2 is square root of pi. So gamma of 3 by 2 is a square root of pi by 2. And substituting this here, we'll get gamma of 5 by 2 as a 3 by 2 into pi by square root of pi by 2 is a 3 square root of pi by 4. So gamma of 7 by 2 is actually 5 by 2 into gamma of 5 by 2. Gamma of 5 by 2 is 3 square root of pi, which is substitute here. You will get 5 3s are 15, 2 4s are 8 square root of pi. 15 by 8 square root of pi. So this is how you find gamma values. First, you need to remember gamma of 1 by 2 is square root of pi, and then gamma of n plus 1 is n gamma of n. Okay. But what about gamma of negative values? Okay. So in case of negative values, minus n in the gamma, inside of the gamma, if you have minus values, it is n plus 1 gamma over minus n, if n is less than 0. Okay. So here we have minus 3 by 2, minus 3 by 2. So this can be done as minus 3 by 2 plus 1 over minus 3 by 2. Okay, and this is actually minus 1 by 2 gamma, and minus 3 by 2 is actually minus 2 by 3, right? So again you have minus term here. It is not still yet plus 1 by gamma of 1 by 2. So again, if you minus 1 by 2, gamma of minus 1 by 2 is minus 1 by 2 plus 1 gamma over minus 1 by 2. In place of n, I am substituting whatever the values inside. That's what I am doing here. So it is gamma of 1 by 2. In the denominator I have minus 1 by 2, so 2 will come to the numerator and minus 2 also come to the numerator. So it is minus 2 gamma of 1 by 2. Okay. So again, now we ended up at gamma of 1 by 2, right? So any value, any term with gamma can be converted to gamma of 1 by 2 using these two formulas. These two are same formulas. If you send this n this side, it will be n plus 1 by n, right? So that's what it's here. But if you have negative sign in n, you have to have negative sign in here. Okay. So what is gamma of 1 by 2? Square root of pi. So gamma of minus 1 by 2 is minus 2 square root of pi. Minus 2 square root of pi. Okay. So gamma of minus 3 by 2 is minus 2 by 3 into minus 2 square root of pi, which is gamma of minus 3 by 2 is minus 2 by 3 into 2 minus 2 is plus 4 by 3 square root of pi. Okay. So this is one value we need and this is one other value we need. Okay. So using these two values, I can write it as gamma of 7 by 2 is 15 by 8 square root of pi. So that is 15 by 8 square root of pi. By you can write s power 7 by 2 as it is, or I'll write s cube square root of s. You can leave it like this or you can write it like this. This is from laws of exponent. Okay. Plus gamma of minus 3 by 2 is 4 by 3 pi. 4 by 3 square root of pi by s power minus 3 by 2. If you have negative sign in the denominator, it will go to, if it go to the numerator, it will become plus. So it is s power 3 by 2 in the numerator. S power 3 by 2 is actually s square root of s. Okay, this is f of s. Again, you can just leave s power minus 3 by 2 as it is, but you cannot leave gamma values as it is. You have to convert, you have to find the value of gamma using these three formulas and write it in terms of square root of pi. Okay, this is also very simple, but it required you to know the knowledge of gamma, these three formulas, gamma formulas. Okay, so from the next videos, we will start solving problems using properties of Laplace transform. Okay, so that's it for this video. So the simplest way to improve your CGPA is by studying the previous year question papers, and this works for all branches, any subjects, and for engineering math subjects, especially for M3, we have prepared an e-book, solutions to previous year question papers and model papers, that I think will help you enormously. Okay, I will leave the link to the e-book in the description. Please go check out our e-book. And if you are somebody who don't want to take any chances and prepare thoroughly for the examination, and if you are somebody who needs help understanding the solutions that are written in the book, you can check out our course, which is amazing and self-paced and very affordable. And I will leave the link to the course in the description. Please go check out our course.